Northwest Airlines Flight 705 was a scheduled passenger flight from Miami International Airport to Portland, Oregon, with stops in Chicago, Spokane, and Seattle. On February 12, 1963, tragedy struck when the aircraft, a Boeing 720-51B, encountered severe turbulence over the Everglades in Florida. The extreme atmospheric forces caused structural failure, leading the plane to break apart mid-air. All 43 passengers and crew members on board perished in the disaster. The crash of Flight 705 became a defining moment in aviation safety, emphasizing the dangers of turbulence and the importance of structural integrity in aircraft design. The Boeing 720 was a variant of the Boeing 707, designed for shorter routes while maintaining many of the same performance features as its predecessor. It was a relatively new aircraft at the time, with Northwest Airlines having introduced it into service only a year prior to the crash. The aircraft operating Flight 705 was well maintained, and there were no known mechanical issues before departure. However, despite being built for durability and efficiency, no aircraft of the era was impervious to the powerful forces of nature that Flight 705 would soon encounter. On the afternoon of February 12, 1963, Flight 705 departed Miami International Airport under normal conditions. The flight crew consisted of highly experienced pilots who were trained to handle a variety of weather conditions. However, as they ascended into their assigned cruising altitude, the aircraft entered an area of severe turbulence. At the time, weather forecasting technology was not as advanced as it is today, and pilots often had limited information about the severity of turbulence ahead. Turbulence is caused by irregular air movement resulting from weather systems, jet streams, and geographical features. In this case, Flight 705 encountered a particularly violent form of turbulence associated with a strong weather front moving across Florida. The sudden and extreme shifts in air pressure and wind speeds put immense stress on the aircraft's structure. As the turbulence intensified, the aircraft experienced rapid, uncontrollable movements. Passengers and crew were thrown violently in their seats, and the airframe began to endure forces beyond its design limits. At this point, the structural integrity of the Boeing 720 was pushed to its breaking point. The excessive aerodynamic stress caused the aircraft to enter an uncontrollable dive. The pilots attempted to regain control, but the extreme forces on the airframe led to catastrophic failure. The aircraft's wings and tail section began to tear apart, and within seconds, Flight 705 broke up mid-air, scattering debris across the Florida Everglades. The breakup of the aircraft made any chance of survival impossible, and all 43 people on board were killed instantly. Eyewitnesses on the ground reported seeing the aircraft disintegrate before crashing into the swamplands below. The wreckage was spread over a vast area, making recovery efforts challenging. Due to the remote location of the crash site, rescue teams had difficulty accessing the debris field. Once investigators arrived, they faced the daunting task of piecing together the events that led to the disaster. The Civil Aeronautics Board, CAB, the agency responsible for investigating aviation accidents at the time, launched a full-scale inquiry into the crash. Investigators examined the wreckage, searching for clues about the structural failure that led to the mid-air breakup. The initial findings pointed to the effects of severe turbulence, which had placed overwhelming stress on the aircraft's structure. One of the key factors in the investigation was the aerodynamic forces acting on the Boeing 720. While the aircraft was designed to withstand significant turbulence, the extreme conditions faced by Flight 705 exceeded those limits. The rapid vertical and lateral movements likely caused a phenomenon known as flutter, an aerodynamic condition where oscillations in the aircraft's structure intensify uncontrollably. Once flutter reaches a critical threshold, components of the aircraft can break apart, leading to complete structural failure. Further analysis of the wreckage revealed that the aircraft's tail section had separated first, indicating that the vertical stabilizer and horizontal stabilizers had been subjected to intense stress. Without the stabilizers, the aircraft would have become uncontrollable, leading to the final breakup. The wings, which also showed signs of structural fatigue, detached from the fuselage as the aircraft descended in pieces. The final report concluded that the primary cause of the accident was the severe turbulence encountered by Flight 705, which led to structural failure. The findings raised concerns about the ability of commercial aircraft to withstand extreme weather conditions and the need for improved weather forecasting to warn pilots of dangerous turbulence zones. In the aftermath of the crash, several safety measures were introduced to prevent similar accidents in the future. Airlines and regulatory agencies implemented stricter guidelines for avoiding severe turbulence, including improved weather monitoring systems and enhanced pilot training in turbulence management. Aircraft manufacturers also began reinforcing structural components to better withstand high aerodynamic stresses. The legacy of Flight 705 extended beyond technical improvements. The tragedy served as a reminder of the unpredictable nature of air travel and the importance of continuous advancements in aviation safety. The victims of the crash were remembered as part of a broader effort to make flying safer for future generations. Although modern aircraft are built with more advanced materials and engineering techniques, turbulence remains a significant concern in aviation. Today, pilots receive real-time weather updates, turbulence forecasts, and onboard systems that help them navigate around dangerous atmospheric conditions. While no aircraft is completely immune to extreme turbulence, the lessons learned from accidents like Flight 705 have greatly improved the overall safety of commercial aviation. The crash of Northwest Airlines Flight 705 remains one of the most tragic examples of turbulence-related structural failure in aviation history. It serves as a powerful case study in the importance of weather awareness, aircraft design, and pilot preparedness. Though the 43 lives lost that day could not be saved, their legacy lives on in the advancements that have made modern air travel one of the safest modes of transportation.